Hello and welcome to day 4, I believe, is it, of my stream. This is the third day I'm actually going to be solving Project Euler problems. So today I'm going to start on problem 5. I haven't started yet on it. But before I get to that, there was a problem I was working on yesterday. Problem 3 was, finding the largest prime factor of this guy over here. And I got a solution to that. The I didn't really like my solution because this program took like 20 seconds to run, and that kind of irked me out a little bit. So what I did was, I tried to find some way of optimizing this piece of code, and I was pretty successful. The first trick I did actually wasn't really that good. So what I did was I said, okay, if the number ends in a 0, 2, 4, 5, 6, or 8, there's no way it can be prime. So I said, okay, let's say it's not prime. That really didn't save me a whole lot of time. I think it took my runtime of this routine down from 21 seconds to 20 seconds. So it's like a 5% I saved about 5% of my time runtime. Uh, Not really that great. So another thing I did was, okay, so what I originally did was I ran through all the numbers up to square root of this guy, check if they're prime, check if it divides this number evenly. That So I changed that routine up. Instead, every time. So now what I'm doing is, okay, every time I find a prime number, I check if it divides it evenly. But I also added this little guy in here. And what I'm gonna do is, okay, if I find a prime number, I'm gonna divide that number accordingly, and it'll decrease my bounds that I'm searching through. And that was super effective. It took my runtime down from 20 seconds to 2 thousandths of a second. So increased the runtime by several orders of magnitude. So that was good, and now I am very satisfied with my problem. So or with my solution. So now let's work on problem 5. So problem 5, I have it up on screen. So what we need to do, let's see, 2520 is the smallest number that can be divided by each of the numbers 1 through 10 without any remainder. What is the smallest positive number that can be divided by all the numbers 1 through 20? So I've actually, thought about this a little bit already. My initial guess was, this is kind of stupid. You just kind of multiply all the numbers 1 through 20, and that wouldn't that be the answer? And no, that wouldn't be the answer, because because we want the smallest such number that's divided by all those values. So let's see. For example, like it would be stupid to multiply like 2 and 16, because whatever numbers can be divided by 16 can also be divided by 2. So it'd just be kind of stupid to take the product of those two. So my idea for this one is, okay, we're gonna take a look at all the numbers 1 through 20, and we're gonna count the number of prime factors that are in each one, and then based on that count of each prime factor for all those numbers 1 through 20, we're going to multiply all those together. So I don't know if that makes sense, but let's just work through this. Import math. So we're going to need to import our isPrime function that I used in problem 3. Let's see, let me close all these other guys. Import math, isPrime, and now let's see. So we want a count, let's see, a count of the prime factors So let's create an empty list of size 21. Okay, so list equals prime factors equals 0 times 20. So what this is going to do is it's going to, let's do it 21 just so the index ends at 20. So what this is going to do is this is going to keep a tally of all the prime factors for every number up to 20, up to and including 20. So let's see. So for I in range 2 through 21, our index to go up to 20. So the idea is prime factor count. Let's call this prime factor count. So I mean, my idea is that if prime factor count, we're going to keep a running product, result equals 1, and if I is prime and prime factor count of I is greater than 0, we're going to multiply our result accordingly. So result is equal to, let's see, math.power. That's power because it's x to the y. Actually, it's going to be result times equals I raised to the prime factors count. So now we need to, and then we're going to print our result to the screen. So we need to fill out this list. So what we need to do is we need kind of some routine. So what we need here is some routine that can count the number of prime factors for an arbitrary value. So maybe what we could do, let's see, so def prime factor of n. So I'm going to create a function that maybe lists out all the prime factors of a given number n. And let's see. For I in range 2 to n plus 1, if I mod, let's do this instead. I'm going to do a while loop. While I is less than n, if n mod I is equal to 0, so it's evenly divisible, and I is prime, so what are we going to do? Oh, let's keep the list of our prime factors. Let's just call this array. We're going to add this to the list. We're going to add I to the list. R.append I, and we're going to divide n by I. Otherwise, if it's not prime and it doesn't divide evenly, ideally if we're starting at 2, we don't even need this is prime function. This actually seems kind of redundant, and I think we should go all the way up to n. Otherwise, we're going to increment I. Plus equals 1. So let's return the array. Return R. Let's check this if this works. So let's print out prime factors of 20. And so hopefully this should give us a list that returns 2, 2, and 5. Let's see, run problem 5. And we have an error, and that's actually inside our while loop. Let me comment this out first. Let's see, and where is getting stuck? Let me separate this out. Local variable I reference before assignment, so we didn't initialize I before our while loop. So let's start off at 2. 2, 2, and 5. That looks pretty good to me. Okay. So now we need to build a running count of all these prime factors. For I in range 2 through 21. So how do we count elements in a list? Let's see. Oh, you know what? So I want, so I could just go through that list. Let's say factors of I is equal to prime factors I. So this will give us our list. Let's say I want like the count of 2's. How would I do that for this? For example, for 225, I want 2 2's, or let's say prime factor 16. I want an array that says 4 for 2, because we have 4 2's. Seems like a pretty easy problem. Count elements in list, Python, count. I don't want the length of the list. Count specific values in the list. Okay. So let us, for j in range, I plus 1, so count temp equals the count. Let's start at 2 as well. count is factors of I dot count j. Okay, and what we'll do is we'll say, okay, if prime factors, if the count in this list, prime factors at index j is less than temp, then we're going to replace that. Prime factors j is equal to temp. And let's see if this works. So print prime, let's go ahead. Oh, that's a function. Right, and it's an array I haven't defined yet. Prime factors count. Okay, let me print prime factors count. So this looks, like exactly kind of what I want. So let's see. Given all our prime factors up to 20, the most amount of 2's that we ever get is 4, so that's for 16. The most amount of 3's we get is 2, that's for 9. 5, 7, yada yada yada. So let's run this guy up here. Comment it out and see what we get. Let's see. Line 52. We don't even need to check if it's prime. Prime factor count is greater than 0. This needs to be a colon. Let's see, or POW. So I think we need to do math.pow I raised to the prime. Oh, I didn't index this guy. Let's see this, if this works. 23, 27. Okay, so this is what I got. Let's go ahead and input this. 51324. Ah, got it. So that, don't know if I explained, what I did too well, but, it works fast. And most importantly, it works. So here you go. Problem 5. Just build a running tally of the largest amount of prime factors that occur in any value up to 20. And then multiply them all together. So let's move on to the next problem. So problem 6. Let me put this up on screen so you guys can see what I'm working on. Let's see, I want to make sure this doesn't take up too much of the screen. But, I'm going to shorten this so you guys can read my code. Find this. Let's just say, let's just do this. Okay. So this one seems pretty easy. Let's see. Let's open a new script. Let's see, file, new. Problem 6. So def sum of, so we're going to create two functions, sum of squares def square of sums, or square of sum. And then we're just going to print, the difference between these two. This one just seems overly simple. So, and we want to do it up to, let's see, find the first 100 natural numbers. So from 1 to 100. Let's see. Okay. And it's going to accept a parameter n. So let's actually write this function. So sum equals 0 for I in range n plus 1. Sum plus equals I squared. And then return that. There's actually a faster way to do this. There's actually a formula for this. It's kind of an extension of the triangle formula. I don't know if you guys remember, we actually don't need this for loop. But if we want to say sum up the numbers 1 plus 2, sum up the numbers 1 plus 2 plus 3 plus all the way up to n, this can be written as n times, I think it's n plus 1 over 2. It might be n minus 1 over 2, but there's a quick little, there's a similar formula for adding up, say, 1 squared plus 2 squared plus 3 squared all the way up to n squared. Oh, hey Schmorcho, how's it going? So there's a similar formula for adding up 1 squared plus 2 squared plus all the way up to n squared. And so that can have us avoid doing this for loop over here. Let me do a quick lookup for this. Kind of cheating, but I don't think it's too bad. Sum of squares formula for the first n natural numbers. So yeah, it's given by n times n plus 1 times 2n plus 1 over 6. So yeah, I took a look at that problem. I'll do that. I'll solve a couple of these Euler problems, and I'll try to work on that guy. I don't think I'll be able to solve that today, but I think I can at least get started after I solve a few of these Euler problems. Let's see, because yeah, it does look pretty involved. There's a lot of edge cases. I feel, I haven't really looked into it too much, but I feel like there's a lot of edge cases that need to be considered. And it seems kind of tedious, but definitely seems doable as well. So let's instead say result is equal to, so let's just plug in our formula here. This is equal to n times n plus 1 times n plus 1 times 2 times n plus 1 all over 6. And that's our sum of squares formula. Oh damn, so it is pretty tedious, 900 lines. Yeah, that's definitely not something, that's not something I can get done in like an hour or two. Oh, it's pretty impressive, yeah. Let's see. So square of sum, so we'll just say, let's see, sum is equal to n times, is it n plus 1 over 2? And then square this equals sum squared. And so we'll just print the difference. Square of sum 100 minus sum of squares of 100. Let's see if this works. The reason I use Python is it's just an easy language to work with. I used to use C++ for work a lot. And I'm pretty comfortable with C++, but just for kind of like showing this code to other people, I think it's just a lot easier to read. Like C++ has like kind of like all this extra junk in the code that kind of that I just don't think lends itself to readability. So that's pretty much it. It's more just a readability thing. So let's go ahead and try this guy. Four, 5, 6, 9. Sorry, the answer you gave is incorrect. Let's just make sure. I'm sure there's one of these is. Oh, I didn't return anything here. Return sum. Didn't even change my answer. Let's see. Nah, it didn't even change my answer. Let's see. Let me make sure these are working correctly. So print, say 10, print sum of squares of 10. Oh, I'm not even, oh, this isn't even running the right problem. That's why. Okay, so maybe this is the correct answer. 38212. Let's go ahead and check this out. There you go. Okay, it worked correctly. It just wasn't running the right script. Let's try to solve one more of these guys. Let's see. So, what is the 10,001st prime? Assuming primes start at 2. Let me go ahead and put this on screen. So, this one, so the issue isn't really, I don't think the issue is really going to be, can we solve this? The question is, can we solve this quickly? Let's see. So I'm going to just try the naive implementation and see how long that takes to run, or if it even finishes. I'm not sure. Problem 7. Let's, grab our isPrime function from here. So let's start our count at 0. So while I is less than 10,000, or no, while count is less than 10,000, let's see. Yeah, is that what I want to do? Oh, and let's start a counter. Yeah, let's start a num test equals 2. So this is our number 2 test if it's prime. So if is prime num2 test. And what we're going to do is we're going to increase our counter by 1. And in either case, we're going to increment our number to test. And, you know, I don't have a lot of faith that this is going to run quickly or even finish. Maybe not even my lifetime. Well, let's see, it finished. Print. Now we don't have a print num2 test. Oh, num2 test plus equals 1. See what it says. Math, I didn't import the math library. Import math. $10,000, that seems way too small. 104,730. Let's see, C++, yeah, definitely, that's, you know, what I keep hearing, C++ definitely runs faster. But, you know, I think for these problems specifically, I don't think it'll make too much of a difference. They say that, you know, for none of these problems should, for any of these problems on Project Euler, it says that none of them should, you know, have your program running for longer than a minute. And, you know, I'm sure there's like some optimization things going on in the background in C++ that make it, you know, run a little bit faster, but I can't imagine it being, you know, too significant, at least, you know, under orders of magnitude. And, you know, I think for what I'm trying to do, I just feel like readability is just kind of more important, especially like if I'm going to be streaming my code. So I mean, that's kind of just my excuse. So let's see, 10,000, so 140,000. That seems just way too small. So I'm sure I did something wrong in my code. 1i874. Yeah, okay, so let's take a look at this while loop over here. So we're starting with 0 primes. Every time we test a number, we increment our prime counter by 1. And we increment the number we're testing by 1, regardless and we're going to keep doing that until we hit our 10,000th prime, but we want our 10,001st prime. Yeah, I think, you know, I worked on these problems, you know, for the first time when I was in college, and that was maybe like, I'm going to say almost 10 years ago. Yeah, this is the prime function. So it's kind of a naive implementation. So here, I'm just checking if it ends in any of these values, 2, 4, 5, 6, 8. And, you know, this is kind of a special if statement if it's true. And other than that, it's just kind of a naive implementation. We're just going up to the square root of n. And if it's modded by, or if it's divisible by anything, we return false. And if it gets through the entire while loop, we return true. Yeah, so, you know, what I was saying was I first started working on these problems, or, you know, the first time I saw these problems, I worked on a few. I was in college 10 years ago, and I think I did these in C++ originally, because I think that was like the only language I knew at the time. Let's see. So I can't see anything obviously wrong with this. Print out some stuff. If is prime, let's just print out num to test and see if anything gets spit out that looks off. Yeah, it's saying this guy is prime. Or no, that's the num to test. So maybe it should be num to test minus 1 because it adds 1 at the end. So, is that my problem earlier? Yeah, it's giving me an even number. That's clearly not right. I should have just noted that right off the bat. Oh, okay. Well, I guess it ran a lot quicker than I expected. I'm very surprised because we have like a nasty nested loop, but yeah, not bad. Okay. So yeah, so Shmorcho, can you send me the link to that problem you sent me yesterday, just so I can have it up on screen, or just so I can show it. I'll try to work on that. Let me start a new script. Let me call this user problem 1. User problem 1. So let's see. So let's see. So Love Feelings or whoever else is watching. Yeah, Shmorcho sent me a problem the other day, and yeah, it was something about getting the total area of squares on a grid. Let me get the link to it. Let's see. I'll put it up. So, we're going to be given squares. We're going to be given a list of squares, and the input is, or how they define a square is going to be given by its center and one of the vertices on a plane. And we're going to be given several of these squares. What we want to find is like the total area covered by all these squares. So getting the area of a single square is pretty simple. You just need you'll just need like the distance from the center to a vertex, take the area, and you can just come up with an easy area formula from there. Make a generator to get the next prime. That'll be useful later on. Oh yeah? So you mean like turn this into just turn this guy into a function, like get nth prime to k, and just say this goes up to k? Is that what you mean? So yeah, the issue with this problem though is like kind of getting these subtracting out these overlapping sections. So that part, I don't know how difficult it's going to be. I don't imagine it's going to be too difficult, but I do imagine it is going to be tedious, kind of like considering how awkward a lot of these sizes are. I imagine a little bit of it is, finding all the vertices of a square and then like treating them as lines up to a certain point. I'm not sure. But yeah, I guess we could get started on this. That'll be useful. So let me go back to what you're talking about. Let's see. I mean, using the yield statement. Using the yield statement. I'm not really familiar with the yield statement. So you can do for p in next prime. You might have to send me an example of what you mean. I'm not really familiar with yields. So you can do so would the input for next prime be the previous prime? Or would it be an arbitrary number and you'd find the prime after that? So let's see, let's define a square. So def square, maybe we make a class for squares. So class square, and we would, let's see, def, is it initialize? Let's see, how do you define classes in C++? In itself, just pass this. So we need some parameters. We need the center equals, let's just say 0, vertex. We're going to have 4 vertices. So 1 equals 0. 2, 3, 4. So I'm going to define a square class. Let's see, and if we initialize it by, let's see, vertex and edge. So when I initialize a square, what I would like is for it to, what is it, center and edge. Center and vertex. That's what I meant. So what I'd like to do is, when I initialize a square object, I would like it to kind of fill in these values, and I assume that'll help me out later on as I'm working through these problems. So maybe I could define an area variable as well. Area equals 0. So self, center, vertex. So the area is easy. That's just going to be, so I think it's going to be 2. I probably need a Euclidean distance function too. Let me come back to this. We'll define, I don't really need this in the class, but let's see, define Euclidean distance of 2 points, x and y. The Euclidean distance of any 2 points is just going to be return. Let's import the math class in here as well. It's going to be probably going to be important. Return math dot square root of x 0. So for 2 points, x0 minus y0 squared plus, I'll check out that link later. Thanks. Love feelings. x1 minus y1 squared. Let me just kind of test this really fast. So test equals square, let's say with center, I'm just going to say 1, 0. It doesn't matter for now. Run. User problem 1. And let me test the distance between test dot Euclidean distance between, let's say, 2, 2 and 3, 3. So that should be square root of 2. Yeah, good enough for me. So the area of a square is going to be 2 times the Euclidean distance. Oh, what happened here? Lost my... Oh no, Python looks like it froze on me. This is going to fix itself. Yeah, I've never done any math competitions myself. You know, I studied math in college. That was my, I got my bachelor's in mathematics, but I never entered any competitions. I've mostly, I've never really been interested in, say, like theoretical math or like number theory or anything like that. Like, I've mostly been interested in applied math or statistics. Like, statistics is what I got my master's in. But yeah, I consider it fun, but it's never just been an area of focus for me. Okay, it unfroze itself. Let's try this again. Self dot center and vertex squared. So, so when we define a square class, we'll be able to, let's try this. Let's define a square at center, let's say the origin, and it has a vertex at 1, 1. So the total area of this square, it'll have like kind of 4 squares on that grid, so it'll have a total area of 4. Let's see if this works. Test. Test area. Let's see what it says. 0. Let's see. Self.area. There you go. Okay, so it gets the area of a square correctly. How can we get the other 4 vertices? And should I even worry about this? Is this even something I'll even need in the future? I think it will be something I'll need, because I'm probably going to break this up into like lines, and then we're going to take the intersection of a bunch of lines to kind of subtract out all those overlapping areas. Let's kind of skip. I'll get back to that when I need it. Let's say self.vertex1 equals vertex. I think that's good enough for now, and I'll just come back to that. Let's go back to this problem sheet. I'm going to copy and paste this to a text file. I have this here. We call this user problem 1 text file. So I'm going to copy this, and this will be my kind of test data that I'm going to work with. Let's see. And how is this input arranged? So the first line holds the number of squares. Each of the next n lines holds 4 integers. Each describing 1 of the squares. Each square, well, let's see, holds 4 integers, each describing 1 of the squares. So would this be center, and this would be the vertex, or the other way around? I don't think it matters. It shouldn't be too caught up in the input for now. Let me just kind of worry about, how we're going to get the overlapping area of two squares. Def overlapping area of self and another square, and so this guy, this guy is gonna kind of be where I assume the meat of our problem. This is, getting this guy is probably gonna be the most tedious part. So let's think of this. The overlapping area of two squares. So let me pull up Microsoft Paint so I can kind of visualize what I'm thinking about here. So, I have a square like this, and can I rotate this in Paint? Doesn't look like it. But let's say I have a square like this. Can I rotate in Paint? Let me just do lines. So let's say I have a square like this. So how am I going to get this overlapping area over here? Oh. Let's see, where to... Let's see, so, well, what I'm thinking is, okay, we're going to treat this as a line. So, let's see, we're going to treat this, one thing man. Okay, so we're going to start at the leftmost point over here. So first thing I can think of is we're going to take the leftmost point on our square. Let's see. Which starts around here, and we're going to make sure it is less than the rightmost point of our first square. Okay, so I mean, and then of course, and then kind of the similar thing here, we need to make sure our topmost point is also extends into here. Okay, so that gives us a little bit of an idea of, I guess kind of which, if we're even going to check for an overlapping area in the first place, but then, from there, and then we're going to kind of check the area of each square in these ranges. So what we need is we need a way to find out, okay, how much space does, let's call this guy square 1. And this guy is square 2. What's the area that square 1 takes up in this space, and what's the area that square 2 takes up in this space? No, that doesn't sound right, because this side could be, I mean, square 2 over here could be kind of angled in a weird way. And yeah, it's not necessarily, they're not going to be completely overlapping in this space, is what I'm trying to get at. Let me think. Instead, okay, what we could do is just find out the points where these two squares intersect. So that's another thing I'm thinking. Let's find the points where these two squares intersect. So the squares intersect here and here. Yeah, a hint would be great. But yeah. Should I break this up into squares and triangles? Let me show you the current problem. Let me see if I can get it up on my OBS system over here. Probably not, but yeah, the problem is, trying to find, what I'm trying to do is I'm trying to find the total area that a set of arbitrary squares occupy. And the difficult part is trying to account for these overlaps. Yeah, let me post the link in the chat if you want to look at the problem yourself. So yeah, what I'm thinking is, okay, we're gonna, even that seems kind of, I don't know how much I really like that. Would I break this up into squares and triangles and figure it out from there? I mean, I could get this intersection, or this point over here, and then we have a triangle over here, and we could go back to kind of trig or whatever and figure out these areas. It's tedious. I feel like this problem, arrange them like a convex hull problem. And there's a formula to find the total area. So find all the intersections, and it's a convex hull problem. Huh. That is pretty interesting. Is there area of points, area of convex hull, given coordinates? Shoelace formula? Is that what it is? No, that looks like something completely different. I'll take your word for it. So, yeah, let's try to find what that, yeah, I see what you're getting at. So I guess step one should be, yeah, find the intersections. Depth intersections. And square it with another square. So it sounds to me like finding these vertices are going to be important. So let's, in our initialization, we need to find vertex 2, vertex 3, vertex 4, and I don't think that should be too difficult. And let's see, we are also going to, there's also going to be, yeah. Oh, it is the shoelace formula. Okay, I'll take a look at that. Sketch io.render. Let me take a look at this link. P1. Oh, yeah. Let's see. Okay. No, I found the 10,000 first prime a long time ago. I expected it to be kind of a slow algorithm, but it actually ran pretty fast. This is a problem. Let's see. Yeah, this problem, I put it up in the chat a second ago. You can take a look at that. So let's try to find these other vertices. Does the math library have sine and cosine? Let's see. Math.sine. Yeah, it does. So how do I find these other vertices? I'm gonna have to go back to algebra to think of this. Let's see. So if I have the center, I don't know which vertex I'm getting either. I don't think it really matters. It's been about an hour. I only planned on streaming for about an hour a day, and this is a perfect time for me to take a break. I'm gonna think about this a little bit throughout the day about how I'm gonna approach this, and I'm gonna kind of speed this up tomorrow. But yeah, I really appreciate the feedback, guys, and yeah, thanks for the problem, Shmarsho. It's a really interesting problem, and I'll keep thinking about it today. So yeah, thanks for tuning in, guys. Have a great rest of your day.